Good morning, boys and girls. Welcome back to the southern wing of the Stink Bug Works. Before you is something you rarely see. A clean Stink Bug Works. The box of parts that needs to be put away, that usually lives there, has been put away. This box of parts we'll talk about in a moment. This box of parts is, for all practical purposes, ready to go. I put in the 1800 battery and I moved the speed control from here, but I left the Velcro just so I can move things around, and moved it back to here. And with a little bit of jam foam, the battery sitting on top of the Velcro just stays right there. Bingo. It's ready to rock and roll. And with a little weight aft, I think it'll reduce any hop tendency. If any boat's going to hop, it'll be this one. Just because of the angle I've got in the drive shaft. So I'm compensating for that before it even sees the water. This guy is all white. Couple of pinholes to fill, but all in all, he's in pretty good shape. She's ready to take red paint. She's going to be the Miss Budweiser. And then lastly, my next project. You know how it is with us boat guys. I'm sure you guys are that way too, that you've always got to have something in the works. And this is an interesting comparison. You saw all the crazy ass stuff I did here to make it cool and bitchin' and all that. And you saw how I went through this and just did quick and dirty. So there are a couple of different approaches. God, I'm embarrassed to say how old I am, and my voice cracks like I'm a teenager. Oh, well. Anyway, so it's kind of an interesting comparison between the two builds, the similarities and the differences. I mean, this got an uber complicated drive system. This got the simplest thing I could find. And it kind of went around from there. Interesting to see different approaches, especially coming from the same shop. And here's going to be a new approach. This is my next project I'm thinking about. And I have the design for the sponsons and the wing. I could build those today, but I have some drawings I got to work on. I got to be able to pay for all this boat stuff, so I got to work on some drawings. But once that's done, the tub and the steering could be plan A, plan B, plan C, plan D. They could be interchangeable. That's part of my layout of this thing. I'm going to make a sponson, a wing section, a space for the tub, a wing section, and a sponson. And then the tub, since it's just a square-sided box of Depron, could be any one of a number of things. I could put a rudder back here if I wanted. What I did here, though, is I put the propeller right at the trailing edge of the sponson. Now, in a hydroplane, everything's riding up way past the sponsons, and so the further back the prop is, the longer the boat appears to be in the way it handles. If this prop were back here 23 feet and the sponsons were the appropriate width, it would handle like a full-sized, boat. It would handle that kind of water just because it's 23 feet long and, 16 feet wide. So the longer the better. But in this canard, my thinking is the prop depth. See, now with the prop 23 feet back there, if this thing goes like this, it's way underwater, or this is way up in the air. But if the prop is right at the trailing edge of the sponson, in theory, the prop should always be running at the same depth, and any change in angle is going to be relatively minor. You're not going to, if you have a 45-degree change in angle, your right angle, you have other problems than prop depth. That's the last of your problems. You got other things to deal with. So that was my thinking on that. See, this whole canard thing, people have tried it, and they always come out similar. Let me relate an interesting story. I studied architecture in the university in San Luis Obispo, and we were given a design project. And the instructor showed examples of what had been done in previous years. Well, everybody, except one, everybody in that class came up with a design that reflected what the other people had done before. They never really thought about the problem. They said, oh, here's a solution that somebody did. I'm going to take that solution and I'm going to put a chrome bumper and fins on it. And another guy says, well, I'm going to take that and I'm going to put, porthole vents and fender skirts on it. But it's still the same thing, if you follow what I'm saying. One guy in the class, yours truly, one guy in the class looked at the problem and said, oh, well, the solution doesn't lie in that direction. The solution lies in this direction, and I went off over that direction to solve this design problem. Without going into a whole lot of details, that was the basic idea. And so we come to canards. Everybody and their brother who's ever designed a canard has always had a fixed ski on the front of it. And let's think about it. When you're going around a corner and the center of mass is in a canard is further back here, when you're going around a corner, your front ski is sliding sideways. It's not very efficient. It has to be impacting the way the boat corners. And that's why I'm trying to think outside the box and saying, let's articulate the ski. So it could be Fulton's Folly, a boat powered by steam. Who does he think he is? It could be something far worse. So anyway, that's this box. So there you go, boys and girls. Getting close to done. I should really put some flotation in this and call it done. And until next time, boys and girls, jet out.